Welcome to another edition of Final Countdown. This is week 11, day 1. Week 11, day 1. Let's jump into the 2009 A-level exam paper. 2009 A-level exam paper. Right. First question. SI unit of activity. Activity is given by Becquerel. Activity is given by Becquerel. Moving on. Energy of a photon of frequency f is given. Dimensions of h. Remember, h is equal to energy over frequency. So energy dimensions you all know. ml square t minus 2. Frequency is t minus 1. So it's going to be ml square t minus 1. ml square t minus 1. We have answer number 1. Answer number 1. Moving on. In an astronomical telescope has objective length focal length f0, IP is focal length fe. The telescope is in normal adjustment. Total length and magnifying power of the telescope. So normal adjustment means, all of you all know, object is also at infinity, final image will also be at infinity. So light rays coming from infinity will converge at the focal plane or focal point. Image from the objective lens will act as the object for the eyepiece. So this is Fe. So length is f0 plus Fe. What about the magnification? What about the magnification? Well, magnification is f0 divided by Fe. f0 divided by Fe. So we look at this. Directly answer number 5. Directly answer number 5. Right. Moving on. A metal plate is illuminated with light of certain frequency. Which of the following determines whether electrons are emitted or not? Now, all of you all know HF equals 5 plus KE max. Whether electrons are emitted or not depends on the incident frequency should be greater than the threshold frequency. Should be greater than the threshold frequency. Threshold frequency depends on the metal. Metal to metal, threshold frequency will change. So, what is the answer? Material which the plate is made. Material which the plate is made. Question number 5. A transformer having which of the following characteristics is suitable to produce 220 volt AC voltage? So there is a voltage reduction. 220 volt to 20. So step down. So Vp over Vs equals Np over Ns. Primary to 20, secondary is 20. Np over Ns. And Ns over Np will be 1 over 11. Ns over Np will be 1 over 11. So step down transformer 1 over 11. Correct answer is answer number 2. Correct answer is answer number 2. Question number 6. Magnitude of the charges stored in the capacitors A and B. ठीक क्या होंगे? Now here, how are these capacitors connected? Well, these capacitors are connected parallel to each other. So if I apply Kirchhoff law here, this voltage is acting across this. Is it clear? Next is what? If I apply Kirchhoff law here, this voltage will act across this. So 2 volt there, 2 volt here. So all of you can see Q is equal to CV. 3 microfarad. 3 times 2, 6 microcoulomb. Then Q is equal to CV here. capacitance is 2 microfarad, voltage is 2, 4 microcoulomb. So A and B, if I take separately, A is 4 microcoulomb, B is 6 microcoulomb. Answer is answer number 5. Answer is answer number 5. Question number 7. Whenever you see this, remember least count is given. Right. There is no zero error in the vernier caliper. What's the length? Check where the vernier scale 0 is. So this is 10 millimeter, 11, 12, 13, 14, 15. Reading is main scale plus vernier scale. Between 14 and 15 millimeter. 14 millimeter. 14 millimeter. Right. Thus, so when they give like this, actually it's 0.05 millimeters. Okay. Vernier scale. Which vernier scale division is in line? Looking at this, the 10th division is in line. Now when you are doing a measurement here, least count, value of one main scale division is 1 millimeter. To get a least count of 0.05, how many vernier scale divisions should be there? If you do the simplification, 100 divided by 5, 20 vernier scale divisions should be there. That means there are some more divisions in between, they have not shown. Anyway, 20 divisions should be there. That means directly we can take 10. 10 times 0.05. So 14.50 millimeters. If I write in centimeter, 1.450 centimeters. 1.450 centimeters. So actually, all the answers here are wrong. You must keep it for 3 decimal places, but there is no other option. 1.45. 1.45. Right. Moving on. A person cannot clearly see objects beyond 50 centimeters from his eye. So he is short-sighted. Directly you can say short-sighted. Short-sighted. In order to see objects, in order to see distant objects, that means infinity, what should he wear? So concave lens. Light rays coming from infinity must form the image where his eye can see. Image of the lens is object for the eye. And eye is close by. 50 centimeters from the eye. Light rays from there will converge on the retina. Light rays from there will converge on the retina. So here you go. 1 over V minus 1 over U equals 1 over F. Object at infinity, image formed at 50. Focal length of the lens plus 50 centimeters. Plus 50 centimeters concave lens. So concave lens, focal length 50 centimeters. 8th one, answer 3. 8th one, answer 3. These are all these questions you have seen it earlier, so experience. MCQ number 9. Minimum amount of heat that is necessary to melt completely an ice cube of mass 30 at 0 degrees Celsius. So delta Q is equal to latent heat of fusion. Mass of 30 grams convert to kilograms. LF is 3.3, 10 to the power 5. 1 0 cancel off. 9.9 10 to the power 3 joules. 9,900 joules. 9,900 joules. Right. Question number 10. Question number 10. Figure shows the path of an electron traveling along an arc of a circle of radius r. The magnitude of the magnetic flux density is given by. Now, going in a circle means somebody is providing centripetal force. Who is providing centripetal force? Magnetic force is providing centripetal force. M v squared over radius r. One velocity will cancel off. They want magnetic field. mv over qr. mv over qr. So q is going to be charge. Charge is going to be ER. mv over ER. mv over ER. Answer number 4. Answer number 4. Right. MCQ 11. MCQ 11. The moment of inertia of a spinning star is dropped to 1/3 of the initial value. The ratio of the new kinetic energy. Now think. Rotation in the universe takes place upon a law of conservation of angular momentum. Angular momentum is concerned. Okay. So, L is constant. So, the relationship between angular momentum and kinetic energy is given by this equation. Angular momentum is constant, E is equal to L squared over 2y. So, new rotational kinetic energy divided by initial rotational kinetic energy. Angular momentum over 2, I over 3 reduces to 1/3. L squared over 2y. Simplify the relationship. L squared 2y cancel off. Ratio is 3. Answer number 3. 11th one, answer number 3. 11th one, answer number 3. So, this stands for angular momentum. This stands for rotational kinetic energy. I stands for moment of inertia. E stands for rotational kinetic energy. Now, in linear motion also we have a similar equation. What is it? P squared equal to V. Here, L squared equal to I. Right. MCQ 12. A uniform copper wire cross section carries a current 1.6. If there are 10 to the power 29 free electrons per cubic meter, what is the drift velocity? I is equal to ANEVD. Current in the circuit 1.6 amperes. Cross sectional area 10 to the power minus 7. 10 to the power 29. Charge of electron 1.6 10 to the power minus 19. Drift velocity is there, Vd. So make Vd the subject, you can cancel these two off. Vd is equal to 10 to the power 10, 10 to the power 3, 10 to the power minus 3 meters per second. That's 1 millimeter per second. 1 millimeter per second, answer number 1. 1 millimeter per second, answer number 1. Look at this. In the circuit shown, ammeter voltmeter represents in which circuit ammeter will have the highest risk of getting damaged. So if the ammeter is protected, there should be a resistor in series with it. Which circuit we have a bigger chance for damage to occur. So biggest chance means when what? Maximum current passes through it. So here voltmeter is connected, ideal voltmeter. So no current in the branch. This is safe. Here there is a large resistor in series. This is also safe. Here voltmeter connected here. Anyway in the main current, In the main circuit, there is no current. Safe. Here, current is passing through larger resistor, so all the current will go through this. These are risk. Next is what? And this is connected in series. So series connection means more current. So biggest risk is this, right? Across the ideal voltmeter, no current. Across this one, the 10 kilo ohm. So all the current will go through the smaller resistor. So this can burn out. Answer is answer number 4. Answer is answer number 4. Right. If the absolute value of the surface tension, the temperature of sun were 3 times existing, value of the radiation of the sun would have been mostly in rate of radiation energy emitted directly proportional to 4th power of absolute temperature. 4th power of absolute temperature. So what happens here is the sun will radiate almost any type of radiation. Yeah, any type of radiation. So you have Stefan's law here. You have Stefan's law here. And lambda max into temperature is constant. Wheel's displacement equation. Wheel's displacement equation. Now look at this. If the temperature is triple, then there should be a comparison. Yeah, there should be a comparison. So, larger the temperature, it will go to these two ranges, either ultraviolet or X-ray. It can't be these are anyway very small. It can't be these. Yeah, it can't be these. So, and also for a particular temperature, current temperature is not given, current temperature wavelength is not given, so difficult to compare. So it's either between ultraviolet X-rays. So most probably that's the reason they have given this as well. Because they have not given you a temperature to compare. And you have to remember these, there is no need to remember these values. So generally what happens is, when the temperature increases, it will move from ultraviolet. So it's either ultraviolet or X-rays. But no temperature is given, so therefore there is no way to compare. So all is here. All is here. Okay, no? Question number 50. A non-viscous fluid of density flows through the pipe. If the pressure P and a point where the velocity is V, what's the pressure when the velocity is 3V? Here. So Bernoulli's equation, P plus half d V square, P plus half d 3V square. Pressure P1, P plus half d V square, half d 9V square, minus 8V square divided by 2, P minus 4dV square. 4dV square, answer number 2. 15, answer number 2. 15, answer number 2. MCQ 60. MCQ 60. Non-viscous incompressible fluid flows through a pipe. Smaller area, larger velocity, larger area, smaller velocity. From here to here to here, area is same. Area is same means velocity is same. Then area becomes bigger, velocity drops. Here velocity is large. Here velocity drops side. So looking at this, what can you say? Constant velocity from B to E. Then again the area further increases, again major drop. Correct answer is answer number 4. 16, answer number 4. 16, answer number 4. Right. 17. A person simultaneously drops an object and throws another object vertically downwards from a certain height. Which of the following graphs best represents the VT graph? A represents the dropped object, B is the thrown object. So dropping object means starting from rest. Thrown object means starting with the velocity. But both are falling down under gravity. So the gradient should be the same. Gradient of VT graph should be the same. This is the key point. This is the key point. So looking at that, most suitable answer is answer number 1. Most suitable answer is answer number 1. MCQ number 18. MCQ number 18. A light ray deviates from prism with minimum deviation 30. If the angle of the prism is 60, the refractive index of the material is n is equal to sine A plus delta minimum divided by 2 sine A divided by 2 sine 30 60 plus 30 divided by 2 sine 60 divided by 2. 90 divided by 2 is 45. 60 divided by 2 is 30. 1 over root 2 half. 2 over root 2. Correct answer is root 2. Answer number 4. Answer number 4. Right. A light wave of frequency 4.5 Hertz, 10 to the power 4, wavelength in a certain medium. If the velocity is given, what's the refractive index of light in the medium? Refractive index of the medium is C over Cl. Speed of light in vacuum 3 10 to the power 8. Speed in the medium 4.5 10 to the power 14 into 4 10 to the power minus 7. Simplify the relationship carefully. 3 10 to the power 8. 18 10 to the power 7. So 30 over 80. 6 times 5, 6 times 3. 5 over 3. 5 over 3 is answer number 5. 5 over 3 is answer number 5. Is that easy one? Question number 20. The best vacuum that can be achieved in the laboratory has a pressure velocity. The number of gas molecules present in 1 cubic centimeter. So PV equal NKT. Pressure is 10 to the power minus 30. Volume is 1 cubic centimeter. Number of molecules we don't know. 4 over 3 10 to the power minus 23 into 300. Simplify this. 10 to the power minus 90. 3 times 1, 3 times 100. 4 times 10 to the power minus 21 into 8. Positive 21 means 10 to the power 2 divided by 4, that's n. 100 divided by 4 is 25. 25 molecules are present. 25 molecules are present. There you go. So you can see it won't take long for you to solve these problems easily. With the amount of experience gained, doing this is it's going to be very simple. Right, moving on. Moving on to the structured essays. Right. First structured essay looks like hair tube, but be careful. Right. Figure shows an experimental setup of hair apparatus used in a school laboratory to measure the relative density of liquid. In figure, water, liquid are labeled as A and B respectively. So these water, these are liquid. Right. Water and liquid. Given approximate value for the diameter in centimeter of the tube used in hair apparatus normally, generally around less than 1 centimeter or less. So normally you can say around 0.5 centimeter, that's a bit okay. So diameter is about 0.5 centimeter, less than 1 centimeter. Otherwise you can't find the capital size. Okay. Next. Name the measuring instrument that is not shown in the figure but needed for this experiment. So to measure the rise we need a meter ruler, or we can say linear scale, linear scale. State clearly how you establish and maintain the liquid level in the arms of the hair apparatus. So what do? We suck the air from the rubber tube and we clip it, and we maintain the height of the liquid column here. So you can write there. State clearly how you would establish the particular height. So we suck the air out of the rubber tube. You can write there. We suck the air from the rubber tube until water and liquid rises. And we close it using the clip. Okay. So this one done. What is the special advantage of this method over the U-tube? First method, we can compare the densities of liquids which mix with each other. Right? We can compare the density of liquids which mix with each other. U-tube will be invisible, here mix with each other. Right? Part B. In order to determine the surface tension as well as density, a student has modified this experiment, replacing its both arms with identical capillary tubes of internal radius simple r. Let P naught be the pressure of air above the water, and HW, HTB, HL be the heights of the columns. dW, dL be the densities, and TW be the surface tensions of water. If PW, PL are the pressures at points W and L, write expression for PW and PL in terms of the relevant parameters. Angle of contact of water is 0. Right. So now you have a very good question there. So what I'll do is this. Just show it here. Angle of contact is 0. So radius of bubble equal radius of tube. So here the pressure is P naught. Just slightly below I will take P1 to HW That is the pressure at PW. So if I write this, there you go. P naught minus P1 2TW over radius. P naught minus 2TW over radius. P1 plus HW dWg. That is equal pressure at PW. P1 is P naught minus 2TWR plus HW dWg, that is equal to PW. So I can write here easily. PW equals P naught minus 2TWR HW dWg. HW dWg. Similarly on the other side. PL. P naught minus 2TL over R HL DLG. HL DLG. Right. But don't forget, here the pressure PW is actually equal to atmospheric pressure. Here the pressure PL is actually equal to atmospheric pressure. Why? Because the pressures at the same level are equal. Pressures at the same level are equal. Right. So moving on a bit forward, derive an expression for HW. So what can you say? P naught minus 2TW over R HW dWg equals P naught over 2TL over R HL dLg. Make HW the subject. You can see here P naught cancel out. HW dWg dLg HL. Take to the other side. 2TW over R minus 2TL over R divided by dWg. HW is equal to dL over dW. dL over dW. HL plus 1 over dWg. 2TW over R, 2TL over R. There you go. So from here, you can build a relationship. And the relationship is of the form y is equal to mx plus y is equal to mx plus y is equal to mx plus if you draw graph HW, if you know the values of dW, TWG, what quantities should you extract from the graph to find surface tension? The surface tension you can find directly by what? The y-intercept. Surface tension, y-intercept you can find. Y-intercept you can find. But y-intercept has the surface tension part. dg you can find using the gradient. Okay. Why is it always suitable to have heights of water and liquid columns as large as possible? Easier. The fractional error of the measurement. The fractional error of the measurement. Fractional error will be less. when measuring HW and HL. So the fractional errors will be less. Fractional errors will be less. Okay. Right. Second structure. Structure number 2. Right. So this looks to be a very famous question that you know. The apparatus shown in the diagram can be used to find the thermal conduction of the metal. Right. Thermal conduction of the metal. A uniform rod of cross-sectional steam at 100 degrees is passed through the chamber, and the temperature theta of water in the calorimeter is measured. Right. So theta here is measured. Here 100 degrees Celsius. Right. Going on. First question. Why is steam used in the experiment? What's your answer? So why are you using steam? Because we can maintain this end at 100 degrees Celsius for a long time. Right? We can maintain one end of the rod at 100 degrees Celsius for a longer time. 1 degree Celsius at 100 degrees Celsius for a longer time. Right. The variation of the above mentioned temperature, with time is given below. According to the graph, after T equals T1, here T1, it attains a steady value. What is the reason for this? Why has it attained a steady value? Look at this carefully. It's not insulated. That means the rate in which heat conducted and the rate in which heat is lost will become what? Same. So rate in which heat is conducted and the rate in which heat is lost become equal. So temperature becomes constant. Right there. It has reached a steady value because the rate in which heat is conducted through the rod. Is equal to the rate in which heat is lost to the environment. Therefore, constant temperature is reached. Okay. Right. From 0 to T1, the variation of temperature with time is non-linear. There are two main reasons for this. What's happening? So, what's the reason? Why is it non-linear? Heat is being lost to the environment from the beaker. And the water. That is one. Next is, if I show it here itself, rate in which heat is conducted is K times A. Delta theta over delta L. So here 100 minus theta over L. When this temperature increases, the difference will reduce. Q dot P also what? Reduce. Rate in which heat is conducted. So those are your two reasons. So if you go back, so your two reasons are first one, what is it? Heat is lost to the environment from the beaker, from the water and the calorimeter. Heat is lost to the environment from the water and the calorimeter. Heat is lost to the environment from the water and the calorimeter. Second one, when temperature of water increases, the rate in which heat is conducted will reduce. The rate in which heat is conducted will reduce. The rate in which heat is conducted will reduce. That's the reason. What is the temperature achieved by water at steady state? So steady state temperature there is 60 degrees Celsius. So here the answer is 60 degrees Celsius. Right. It has been found out from a separate cooling experiment that the rate or heat dissipation from the calorimeter and its contents is given by the relationship here. Calculate R for steady state temperature. So R is equal to 0.16, temperature is 60, room temperature is 30. 0.16 into 30, 0, 4.8 point. 4.8 point. So these are very basic calculations, 4.8 point. Right. Hence determine the thermal conductivity of the metal at steady state. Rate in which heat is conducted and the rate in which heat is lost to the environment both are same. K times A delta theta divided by delta L. Here it's 4.8 volt. Thermal conductivity we don't know. Cross-sectional area 1.2 10 to the power minus 4. Temperature gradient 100 minus 60. Length is going to be how much? Length is going to be 0.4 meters. That is equal to 4.8. Simplify this. 3 here. 0.41, 3 here. 3 means 1.6. 1.6 10 to the power 4 divided by 40. 0.04 10 to the power 4. 400 watt per meter per Kelvin. Then 400 watt per meter per Kelvin. Watt per meter per Kelvin. If the calorimeter is also light built, could you perform this experiment successfully? Answer is no. Why is that? If it's lagged, there is no heat loss to the environment. No heat loss to the environment means steady state cannot be reached. Like that. Answer is there will be no heat loss. Answer is no. Reason. There will be no heat loss to the environment. There will be no heat loss to the environment. Since there is no heat loss to the environment, steady state temperature cannot be reached. Steady state temperature cannot be reached. Steady state temperature cannot be reached. Right. Okay. Essay question. Write down Bernoulli's equation, identify each and every term. So P plus half rho V square plus rho GH is constant along a streamline. constant along a streamline. Okay. Right. So you can define this. P is pressure or work done by pressure per volume. Half rho V squared is kinetic energy per volume. Rho GH is potential energy per volume. Okay. Potential energy per volume. You know this. So they are giving you three stages. Stage number 1, stage number 2 and stage number 3. Right. They are telling you stage number 2, width of the channel flow in both the stages are 0.5 each. So these points are good. Stage 3, shallow channel, width is 10 meters. Width is 10 meters. So here 10 meters. And there you right. So okay. First question. At steady state, the waterfall carries a volume of 1.5 cubic meter per second. Speed of water at exit 10. Here 10. Calculate the height of water. So volume flow rate 1.5 cubic meter per second is area into velocity. Cross-sectional area, width is known 0.5, depth we don't know, velocity is 10. Depth is equal to 0.3 meters. Depth is equal to depth of water, height of water is 0.3. Assuming that the height of water level in the shallow region in stage 3 is equal to the height of water in level 2, right? Calculate the speed. Same. 1.5 cubic meters per second. Area is 10 meter into 0.3. Velocity in stage 3. V3 is equal to 0.5 meters per second. 0.5 meters per second. If the speed of water flow at the horizontal channel of stage 1 is 5 meters per second, calculate the height of water of the open channel stage. So they are asking here same volume flow rate 1.5 cubic meters per second. Area is 0.5 into depth, let's say height h1 into velocity 5. H is equal to 1.5 divided by 2.5. 3 over 5, 0.6 meters. Right. Part B. Considering a streamline along the top surface of water, calculate the height y of the channel flow of stage number 2 at x. You may assume that the water leaves to the atmosphere at pressure P at the outlet of the reservoir, and water enters the shallow region X. This is also at pressure P. Let's go back to the diagram. Right. So they want it here. So we can consider streamline coming there. Streamline coming there. Top surface velocity we know. Bottom surface velocity also we know. So we can do the substitution. So if I erase this a bit, so here you go, water height here 0.6, water height here in the beginning itself, stage number 1 or stage number 2, 0.3. 0.3. So one is 0.6, the other is 0.3. We can take this as Gp equal 0.9. Gp equal 0.9. Open to the atmosphere here P. Open to the atmosphere here P. Here velocity is 5 meter per second. Velocity at stage number X. Velocity there. How much? They have given you 10 meters per second. Right. Now apply balloon. P plus half rho velocity square. Rho g y plus 0.6. Atmospheric pressure half rho velocity square. Stage number 2, what is the velocity? Stage number 2, 0.5, huh? 0.5. Height is 0.3 meters. So it's not difficult. Carefully we apply. Pressure P cancel off. Rho cancel off. 1000 divided by 2 is 500. 10 times y plus 0.6. 0.25 divided by 2, 0.125. Here 3. 500 plus 10y plus 6. 3.125. Sorry. Here it's 100 divided by 250. Right. Check the velocities again. Stage 1, stage 1 is 5. Stage 1 is 5. Stage Stage 2 is 10. Right. Small correction here. So stage 1 is 5. Stage 1 is 5 velocity. Stage 2 is 10. Be careful with the velocity, it can go wrong. 5 square, 10 square. So 50 here. 25 divided by 2, 12.5. Right. So 10y 53 minus 18.5. 53 18.5. 34.5. Y is equal to 3.45 meters. Okay, na? Y equal 3.45 meters. 3.45 meters. Right. Then what? Calculate the height h of the water level in the reservoir to maintain this. Now if I go back, the same picture. Reservoir is very deep, so we can take liquid coming from top. Here also atmospheric pressure, velocity is negligible. Velocity is negligible. Velocity is negligible. So here you can directly apply it and get the height of water. Or from here you can apply it for this situation and this situation. Easy. So if I apply that, be a bit careful. Stage 1.6 is also there. From the datum line, P plus rho G, Y plus 0 plus 0.6 plus H. Velocity is negligible. P plus rho G, Y plus 0.6 plus half rho velocity 10 square. Stage number 1. So 5. Velocity is 5. Open brackets, PP cancel off. Rho G, Y plus 0.6. Rho G H. Rho G, Y plus 0.6. 25 divided by 2, 12.5 rho. Here rho cancel off. Rho cancel off. 10 times H, 12.5. 1.25 meter height. 1.25 meter height. Right. If the water level of the reservoir exceeds a certain value, calculator, propose a method to regulate the water flow. So what's the method? Putting a sluice gate can control the water flow. Control the water flow. Sluice gate can control the water flow. Right. Essay question number 2. Essay question number 2, optics question. Right. Figure shows a monochromatic ray of light entering a spherical raindrop at A and emerging from C after a single refraction at P. If the refractive index of water is 4/3, calculate the critical angle of the water. So critical angle for water means water air goes along the boundary. Critical angle. NW sin C, NA sin 90. NW is 4/3 sin C. Sin C is equal to 3/4.75. C is equal to sin inverse 0.75. 48.6 degrees. Right, given, use it. 48.6. Right. Next one. Giving reasons show that the ray can never totally internally reflect from the opposite surface of the raindrop for any angle of incidence. Right, look at the board now. For total internal reflection, it should exceed the critical angle. So let's say light rays are coming tangentially 90 degrees. 90. So it should go at the critical angle. Goes at the critical angle means will come out tangential. Radius here, here C. So maximum angle of incidence is 90. Maximum R is equal to C. This can never exceed the critical angle. If it can never exceed the critical angle, it can never exceed. It can never exceed. That means R can never exceed, always less than C. Less than or equal to C. Critical angle. Therefore, total internal reflection will never occur. So I have shown for the maximum possible angle of incidence, maximum possible refraction angle is C. This can never exceed the critical angle. So total internal reflection can never take place. Okay. Write down expression for the angle of deviation at A in terms of I and R. So angle of deviation, I'll do it here itself, it's easier. Angle of deviation, here I, vertically opposite towards I, this is I minus R. So angle of deviation at A, I minus R clockwise. Angle of deviation at A, I minus R clockwise. Then what are they asking? Angle of deviation P. So P 180 minus 2R. Angle of deviation at P 180 minus 2R. Again clockwise. Next question. Angle of deviation C. Extend the light ray, here R. Here R. Angle of deviation C, I minus R also continuously clockwise. Okay. So, can go and fill it there. Here I minus R clockwise. Here 180 minus 2R clockwise. Here I minus R clockwise. Hence, write an expression for the total angle of deviation. So I will do this answer here. This answer I will do it here. Total angle of deviation is deviation at A, deviation at P, deviation at C. I minus R clockwise, 180 minus 2R clockwise, I minus R clockwise. All R clockwise means directly you can add 180 minus 2I, sorry, 180 plus 2I minus 4R. Minus 4R. That is in the clockwise direction. That's in the clockwise direction. A rainbow can be seen due to the emergence of incident sunlight from atoms. Since sunlight consists of all visible colors, when white light refracts at A, it separates into colors. Figure 2 shows such refracted ray for red and blue. So here red and blue are shown here. Right. Copy the figure into your answer sheet. Complete the subsequent parts of red and blue rays. So I'll do it here itself. First we'll finish the red one. So red ray will come here. Normal. Here. Deviate red. What about blue? Blue will come here. Blue will come here. Deviate. Red and blue. Red and blue marked. Okay. The expression obtained in C above shows D varies in I. It has been found that I equal 52, blue ray emerges with minimum deviation. Determine the corresponding angle of minimum deviation for blue rays. Right. So you can work the problem out. Refractive index for blue color is 4/3. So NA sin 52, NW sin R. Sin 52.778, 4/3 sin R. Sin R is equal to 3/4.778. This will give you 0.591. R is equal to sin inverse 0.591. R will give you 36.25 degrees. R. They are asking the minimum deviation there. So minimum deviation is 180 plus 2i minus 4r. 180 plus 2 times I is equal to 52 minus 4 times r, 36.25. If you simplify this, you simplify the relationship, you will get 139 degrees. 139 degrees. Then these are blue area, blue color. Assume I52 in your ray diagram drawn in D above. Correspond that color is specially bright, ray bunches up at an angle. These bright color bands, which are minimum deviation, enters the eye and thereby a rainbow can be seen. So you have to mark it. Marking minimum deviation above. So you can mark it here, or I will draw it here again. So here you go. Blue ray enters. Blue color ray enters. Angle of incidence 52. So red will deviate less, blue will deviate more. Right. So your deviation, how do you mark it? Emergent ray extent. This is your 139 degrees. This is where the person is keeping the eye and looking. Okay? Right. Then the last question they are asking you. Sorry. Determine the angle made by blue color with the horizontal. So with the horizontal you can find how? 182, this is 41 degrees. So Z is formed. With the horizontal 41 degrees. So you can mark there 41 degrees. So I have marked it in the picture here 41 degrees. 41 degrees. Which of the color forms the outer edge of the rainbow? So what will form the outer edge? Outer edge is red color. Outer edge is red color. So here you can directly write what? Red color. Okay. Right. So this concludes the discussion. Final countdown, week 11, day 1. So catch you out tomorrow with the next edition, or with day number 2. Work hard, stay safe.